Level 0, 0.1 millisievert. Imagine something as ordinary as eating a banana. Few people realize that this simple act carries with it a tiny amount of radiation exposure. Bananas naturally contain potassium-40, which is a radioactive isotope. Since potassium is an essential mineral for the human body, this mild radioactivity has always been part of our diet. It might sound unusual, yet this exposure is so minuscule that it causes absolutely no measurable harm. The radiation from a banana is not enough to even register on most sensitive instruments that detect environmental radiation. At this level, the death count is permanently zero. Human beings have always lived with such background exposures. Our species evolved under these conditions, which means that life itself has adapted to them over millions of years. It is as ordinary as breathing oxygen or feeling the warmth of the sun. This low-level radiation is not a threat. Instead, it is a quiet, constant presence in our lives, reminding us that radiation is not always dangerous. It is woven into the natural environment, from the food we eat to the soil beneath us, and even the bricks in the walls of our homes. In fact, radiation at this scale is often used as a teaching tool. Scientists sometimes refer to the banana equivalent dose to help the public understand just how low certain levels of radiation truly are. If someone hears about a few microsieverts from flying in an airplane or from living at a higher altitude, comparing it to eating a handful of bananas makes the risk easier to grasp. It highlights that radiation is not an alien force lurking outside our daily lives. It has always been here, part of the Earth, the cosmos, and our very biology. Level 1, 10 millisievert. Moving up slightly, imagine undergoing a few CT scans within a short period of time. The amount of radiation you would accumulate is about 10 millisieverts. At this level, no one drops dead from exposure. The danger is not immediate but exists in the form of probability. Over a lifetime, a small fraction of people might face a slightly elevated risk of developing cancer. Scientists estimate that out of 1 million people exposed, perhaps a few might eventually develop radiation-related illness, and even then, the effects would often not appear until decades later. The death count therefore remains practically at zero. This level of radiation is where exposure begins to rise above the everyday background levels, yet remains far from life-threatening. In fact, millions of patients around the world undergo medical scans that deliver radiation doses in this range, and the benefits of accurate diagnosis vastly outweigh the minuscule risk. For most people, it passes unnoticed, with no effect on their daily lives. To put it in perspective, people living in certain parts of the world naturally receive doses approaching, or even exceeding this level, every year due to high background radiation. Areas with granite-rich bedrock, such as parts of India, Brazil, and Iran, expose residents to elevated radiation over their lifetimes. Yet these populations live healthy, ordinary lives. This demonstrates how context matters. While radiation always carries risk in theory, low levels like 10 millisieverts are far from catastrophic in practice. Level 2, 100 millisievert. Now we enter the territory of occupational exposure. 100 millisieverts is the maximum annual limit permitted for radiation workers in many countries. These are individuals whose jobs place them in closer contact with radioactive sources, such as technicians at nuclear power plants, radiologists conducting frequent imaging procedures, or professionals handling industrial radiography equipment. In reality, workers rarely reach this ceiling since strict safety protocols are in place. The limit acts as a precautionary measure, ensuring that no individual comes close to a level of exposure that might carry significant risk. Consider astronauts aboard the International Space Station, who spend months in orbit. Cosmic radiation outside Earth's protective atmosphere adds up slowly, and over the course of a mission, astronauts can accumulate exposures near this level. It illustrates that radiation at this scale, while carefully monitored, is something humans can endure in specialized circumstances. The risks remain manageable provided safety procedures are observed. Level 3, 1000 millisievert. At this level, we move beyond occupational exposure and into the territory of accidents and emergencies. A dose of 1 sievert is what some first responders received during disasters like Chernobyl or Fukushima. It represents a dangerous, though not always fatal, exposure. While 1 sievert can make a person seriously ill, death does not occur automatically. The body is resilient and can often recover if medical treatment is provided promptly. This is not a dose anyone is allowed to receive under normal conditions. Regulations exist precisely to prevent individuals from ever approaching it. Still, accidents push people beyond safe boundaries. In medical contexts, a whole-body scan does not come close to this level. Certain radiation therapies for cancer, however, can deliver several sieverts, though only to specific tissues. By concentrating radiation on tumors, doctors can destroy malignant cells while sparing the rest of the body. This distinction is critical. One sievert across the entire body is hazardous, whereas carefully directed doses can be life-saving. Level 5, 4,000 to 5,000 millisievert. This range is known as the LD50, shorthand for lethal dose for 50% of the population. Here, even with the best possible medical care, half of those exposed are expected to die. The damage is not gradual and distant, but immediate and severe. The body enters a rapid decline measured in days or weeks. Records of this level of exposure exist in the history of nuclear accidents and medical mishaps before radiation safety standards were as strict as they are today. Patients who received overdoses from early radiotherapy treatments often faced devastating outcomes. In workplaces before modern protections were enforced, unshielded exposure to radioactive materials led to similar tragedies. Level 6, 10,000 millisievert. This level serves as a stark reminder of why regulations, protective equipment, and constant monitoring are indispensable wherever radiation is used. 10,000 millisieverts is catastrophic for human life. At this level, the body's internal systems collapse one after another. Blood vessels weaken and begin to break down. The bone marrow can no longer produce the essential cells required for survival. Organs that depend on a steady supply of healthy cells begin to fail. The damage spreads through every tissue, leading to a devastating cascade of breakdowns. Survival is virtually impossible. Even the strongest and healthiest individual cannot endure the scale of destruction caused by such a dose. Death becomes inevitable, not as a distant probability, but as a certainty. It is no longer a question of if, but only of when. If this exploration into the scale of radiation has sparked your curiosity, sharing it allows others to learn as well. Subscribing ensures that you will be part of the continuing journey into the science of energy, health, and the unseen forces shaping our world. Scientists sometimes use this level as a boundary when designing protective barriers. Nuclear reactor facilities, for example, are built with shielding thick enough to ensure that anyone outside the core never encounters anything even close to this dose. The design of containment structures, emergency plans, and protective suits all take this level as the absolute never-cross line. It represents not only a medical certainty of death, but also an engineering challenge to keep people far away from environments where 10,000 millisieverts could ever accumulate. Level 7, 20,000 millisievert and beyond. At the final level, we reach radiation fields so extreme that they exist only in the most catastrophic scenarios. This is the world at the heart of reactor cores, within the immediate blast zones of nuclear weapons, or in laboratories during catastrophic failures of high-energy equipment. At exposures of 20,000 millisieverts and higher, the body suffers overwhelming damage within minutes. Death occurs in hours at most. There is no medical treatment that can reverse the devastation. Organs and tissues are destroyed beyond repair, and no supportive care can bridge the gap. Here, the death count is absolute. It is the ultimate endpoint of radiation exposure, a level so hostile to life that human existence cannot continue. These are the zones no person can survive, and they remain reminders of the destructive power of uncontrolled radiation.